Hi, everyone, and welcome to one more episode of the Creative Machine Learning Livestream. It's Nono Martinez Alonso here, and today I'm excited to bring you a stream with a little presentation, a little overview on two things, well, maybe three things. One is Stable Diffusion, that is the machine learning or the AI hype that is going everywhere. It's something similar to DALL-E. We can see it in more detail in a second. And the two other things that I want to show today, I've shown some in the live stream before. One of them is imaginAIry. So this is imaginAI, right? I'll show how it's written in a second. And the other thing is InstructPix2Pix. I'm really excited because Pix2Pix was the technology I used back in my master's thesis for a project I published in 2017, I think. And I've been playing around with it. So today the objective is to try to explain to you what these technologies are, high level. We're not going to go in depth, in detail. This is going to be understood, able to be understood by anyone really. So don't worry if you don't know about machine learning today. And we're barely going to see any code, maybe some commands on the terminal later. But I have slides, I have examples, I have playful experiments that I've been performing with this thing. So yeah, let's get started. I would ask you, if you join live, let us know where you're connecting from, if you can hear me and see me okay, and how you found us. And if you watch this video afterwards, please go ahead and leave a comment. Let me know what you like, what you didn't like, if you subscribe, where you're connecting from as well. And I would encourage you to like the video if you're enjoying the content, and don't forget to subscribe and click on the bell if you're gonna get notified when I go live next or when I upload new videos. This is live 96, so I try to do this every week, but I've been missing many of them. But yeah, so without further ado, let's get started. As I said, I have a set of slides that I'm going to be showing here. And hopefully, let me see, I'll put some stuff in here. Hopefully, this is something that you enjoy. And again, don't forget to let me know in the comments what you like. Yeah, everything is loud and clear. I can see Jay Ballera. Hi, Jay Ballera. Where are you connecting from? I would like to see how you found us, or know how you found us, and what you're expecting to see on today's live stream. We will see a demo. Hi, I can see Jose Luis Garcia El Castillo also connected again. So I will ask you, Jose Luis, how long can you stay? Are you going to be able to see some of these experiments? Okay, so for anyone who joins afterwards, please say hi in the chat, tell us where you're connecting from, and I'll be looking at the chat as well. So if you have any questions, feel free to put them there. And okay, so we're gonna get started now. So let's get on with it. One reminder for those of you who are new, you can join the Discord server at nono.mas/discord or go into that QR code. And that last week we did live 95. So I gave an overview, introduction to PyTorch 2.0. We saw how to install it, what it is, and a few examples. We created a Google Colab notebook that you can access on the Discord server or in last video's links. I think you can see it also on the chat. And yeah, as always, if you have any questions about the latest or any previous episodes of Getting Simple, feel free to send them at gettingsimple.com/ask, and we'll try to answer them on the live stream or on the podcast. And we're gonna skip this. So now I've already commented on what we're gonna do today. I'm going to, okay, so Jose Luis is listening while cooking. That's nice. All right, so we're gonna see two things, and I'm gonna record an intro just in case we crop this video afterwards, but if not, we'll just leave it here. We have an intro and some slides, so I'm just set to have some fun. And if you watch this, I probably gonna repeat some stuff next week because this is a slide deck that I'm working on, so it's not finished, but I have a lot of content already, and I'm happy about that. All right, let's get on with it. Hi everyone, it's Nono Martinez Alonso here, and this is an overview, part of the Creative Machine Learning series on imaginAIry. This is a framework that allows for the generation of stable diffusion images with Python. So it has a really comprehensive and easy to use API. Once you have it installed, you can just write a command on your machine to generate, edit, or manipulate images. So without further ado, I'm just going to show you a bit of what it is, why I like it, some of the highlights, and some examples of experiments that I've been running with this tool. So imaginAIry, as I said, they describe themselves as a Pythonic generation of stable diffusion images. Below here is the GitHub link. They, I believe, don't have a website. They just have the README page on that GitHub repository as their kind of main page where you can read all the documentation and how to use it and what it is and what feature it offers. And I'm going to go through a few things that I've really liked, right? So it's called imaginAIry. I think, you know, the command is, at the end of the day, what you run on the terminal is imagine. So I guess it's a play of word with imaginAIry, imagination, or something like that. It's made by Bryce Drennan. I don't personally know him, but I've been using this tool for a few months now, and I'm really enjoying it. So I will give kudos to him because this is a really good thing. And it runs on Stable Diffusion, I think 1.5 to 2.1. So they are catching up. As soon as new Stable Diffusion versions come out, this tool actually adds support to them. So if you want to use the latest Stable Diffusion versions, you can use imaginAIry. The new thing, why I prepared to do this live stream, because I've shown imaginAIry before, is because they added InstructPix2Pix. So they grab the checkpoint model from Hugging Face, and they actually allow you, through the same API, they allow you to generate images also with InstructPix2Pix. I'm going to show a bit, but InstructPix2Pix allows us to just give instructions to the generator and use Stable Diffusion somehow. I haven't yet dug into the details, and it allows us to just say things like, all right, if you have an image, so get this image of a car, say make the car darker, or make it a stone, or, you know, if you have a bowl of fruit, it's like put some vegetables on the plate, things like that. So it's just giving instructions of what you want, what task you want the library or like the framework to do, and it will do it for you. And it also allows for upscaling with a Real-ESRGAN. This is pretty awesome because the initial images that you generate are 512 by 512, but just by passing a flag, you can get this model downloaded on your machine and automatically being used to upscale your images from 512 to 2048. So that's pretty cool because it allows us to do things like generating really high resolution images. And it works on the terminal. As I've mentioned before, one of the main things is that for me as a developer, it's really convenient just to open a terminal window and be able to type some words and have these high quality images generated. It's also really nice for automation if you want to write scripts to automate the generation of many things. It's really easy, and then you can come back to the machine and see that. And the most important thing is that all of these that I've said, it works locally. So in this machine that is an Apple Silicon Mac, everything works perfectly, works in M1 Max, in M1 Pro, in M2, in M1 normal. So I would say it's really convenient and really accessible. It's free and it just uses your own resources. This is in comparison to DALL-E that is behind a paywall. It's 2 cents per image or a bit less if you put lower resolution, and other things that we've also seen on the live stream. All right, so that's an overview on things. So let's now see the fun things. Let's see examples. And okay, and it's customizable. You know, through the terminal, you have many options. You can pass many flags like upscale, show work that I'm going to explain later, and prompt strength, seed, many different things. All right, so to go a bit into detail on InstructPix2Pix, this is a framework that they've described as something that is learning to follow image editing instructions. And here you can see examples. So for example, here they're saying on painting of Van Gogh, they're saying swap sunflowers with roses, and it shows a really good result here. And if you try it, you'll see that some prompts just don't work, some others do. And you also can use different seeds, which will use different initialization weights on the model, and you will obtain slightly different results, sometimes really different results. And as you can see, the description says, given an image and a written instruction, our method follows the instruction to edit the image. What really caught my attention, and this is, you know, they are allowed, let's say, to call it Pix2Pix more than anyone else, because Alexei Efros, you know, from University of California, Berkeley, is part of the same team who developed the original Pix2Pix. Philippe Sola left that research team and went to MIT for a new opportunity, researching and releasing the same type of academic publications. But in here, what we're seeing is that this is a project made by Tim Brooks, or I'm not sure if this is part of his doctorate, I think, under the supervision of Alexei Efros and Alexander Holinsky. Well, Alexander Holinsky, I don't know, but I know that Alexei Efros is the kind of the head of the research group. So it's research contribution by the same people that developed the original Pix2Pix. Okay, and then Real-ESRGAN. I don't know a lot about this one, just that you know, there are tasks that it does really well. Like for example, there is a lot of interest on being able to clean up or create high resolution from low-res pixelated images from things like manga drawings, for example, or cartoons, or real photography, right? So it tries to fill in the gaps, and with the context of the image, it creates a really detailed representation, sort of making up the texture inside of the pixelated image in a way that is pretty good, right? And in some way, this is a method for image compression, because you can store images in really low resolutions, and then use these models, these GANs, to generate a high resolution of it. It won't be the exact same, and it will lose data inside of it, but it will make contextual meaning with the input image that you're given. So for example, if you downsize shapes, the shapes would still look similar, won't be exactly the same, but if you downsize and pixelate symbols and letters and things like this, they would probably not be scaled exactly to the same thing. Even though in the, you know, in the bottom, at the end of the day here, you see the letters in both images, so that also works well. Okay, so here's an example. If I say imagine a banana, it just gives us a banana, right? It's like one of the simplest examples. And if you say now image an apple, so imagine an apple, no image an apple. So here we'll just repeat here. If you say imagine a banana, it generates an image of a banana. This is around maybe 40 or 60 steps of generation steps. We'll see what that means in a bit. And then if I say imagine an apple, it generates an image of an apple. Not all of them are so clean as these images. They're like, you can generate many different images of the same thing with different seeds. And we'll see some examples of that. This is probably more interesting. That is what I've been playing with as of late. This is InstructPix2Pix. In here, what I'm doing, so we're gonna go back now. What I'm doing here is I'm inputting the image on the left. So that is an image that I made with Photoshop. So it says just a circle with a gradient fill. And I'm inputting that image as the input or initial image. And I'm saying, okay, generate images of planets and spaceships. here what you can see on the right, as I interpret this image, is contextually it's creating something that is brighter on the center of the image, and it's generating things that are darker around it, right? Because there is that gradient. And what happens on the white areas, as I realize, is that if you actually start with a prompt from a white image, the noise will start creating little blobs, and then things will start to come out from there. So if I input a white image, probably I get something from this prompt, like you can see on the surroundings, right? And this one is another one. So this one was the same prompt image and a smile. For some reason, I just started trying different prompts from this initial image to see what happened. And as you can see, you get a smiling face there, but you also get smiling here. And here there was something that was starting to appear, but it faded out. And here was another prompt, the same prompt image, and the prompt start. Oh, okay, there's a typo here. Let's clean this up really quickly. All right. All right, and in this one was a star in the galaxy, right? So I would only get, let's say, frames, right? What you're seeing here are animations, and what you would really get from the framework is one frame. There are ways to tell the framework to tell you to show the work for generating the image, from like noise step to prediction to noise to prediction to noise to prediction, stable diffusion. But then I'll show something else later on animation that is a bit different. So this is fairly easy to achieve, right? Like this image generation process or animation. And here we have similar ones. So this is yeah, GIF I have, like a meme I have from a friend of mine. Is a bit scary in the image, but I did a few image tests with this image with different prompts, right? And the results are pretty good, pretty different also. This one, for example, was trying to make the image into a spaceship, like the face into a spaceship. This was trying to make him younger. And this one was trying to add like facial hair, like a beard or something. This one was trying to convert the image into an astronaut, right? And I'm not showing any of the code. We're gonna see that on the command line. I haven't really copied the commands here so you can start seeing, but because the focus of this right now is so we show some of the images that have been generated and the things that you can do more than how to do it. This is one of the things that start being more interesting to me. Is I'm inputting this hand sketch of mine and I'm saying it's a laptop, and that's the image generation process on the right. So it goes from that image into noise and then starts generating, and there's like 40 or 60 different steps. But what's really interesting here is how much the drawing is defining the location and the orientation, the configuration of the image with like a MacBook, right? In this case, a laptop, and how much it resembles the real thing that I drew, right? If we go to the next step, this is where I got to the most interesting experiment that I've done so far with this, at least for my case. Here, the interpolation is really different from everything that we've seen before, even though it looks really similar. But what's going on here is that I'm saying that this is a laptop, the same prompt, but here, instead of showing the diffusion process of the image from noise or the noise of the initial image till the generated image, what I'm doing is that I'm doing that process to go from noise to the generated image with something that's called the prompt strength in different interpolated values. So that means that I'm going from 0 to 8, interpolating in steps of like maybe 0.25 or 0.5, and generating, doing the 60 or 40 steps 8 different times. So it's a lot more computation, but what's happening here is that we're generating a GIF of my initial sketch with an image that gets to be the next one that is the same sketch slightly generated to be it's a laptop, and then we increase that prompt strength until we get to the image that you can see as an output. If we move that below and we get, in this case, 8 steps, what you can see there is that the original is on the left and the generated is on the right, but all of the in-betweens are also generated. So the one on the left, we can say, for instance, is like 0 prompt strength. Then we go to like 1, 2, 3, 4, 5, 6, 7, or 8 or something, right? So we go increasing that value, and then we get that interpolation. So the framework allows us, I mean, I've done a bash script that I can show or I can share, in which what I do is that I generate each of these images individually with a loop in bash. So what we're doing is just say iterate through different values of the prompt strength, so from 0 to 8 on steps of 0.5, for instance, using the same generation seed, so we make sure that we're going in the same direction all the time. This is not super efficient. The other process is more efficient because there is a flag that I'll show later that allows you just to show the diffusion process in different steps. But in this case, that's not possible because we're trying to get to an image in different levels of the generated, let's say, prompt strength, right? And if we go back, and let me just show this in big so you see it. So we get this image completely big here. Right, so what's going on is it's going from my sketch and then transitioning into a laptop. All right, so if we keep moving, any questions there? Okay. And I'll encourage everyone who's connected with us live right now, give us a thumbs up, a like if you're enjoying the video, let us know where you're connecting from, and make sure also to subscribe and click on the bell if you're not subscribed yet to get notified when I go live next or when I upload new videos. All right, so how are we doing? Any questions so far before I keep going? Any comments? Anything? Okay, so okay, so we're here. We're gonna continue in a second. Just wanted to show really quickly that this image was actually also generated with this, and we're gonna see now the same process. So this is supposed to be me doing this, which we have from a previous stream, and that we actually have, you know, that we have been using on the video thumbnails. I can see Joseph Kirkpatrick here from South Florida. Nice. You're joining. How did you find the live stream? I'm curious. What did you come looking for here? All right, so let's keep going, and let me just drink a bit of water here. All right. So we were showing this is an interpolation, and now what we have here are a few learnings of imaginAIry, of the framework, that I'm going to quickly explain, things that I've liked, things that we're going to detail a bit more, and that I think are useful if you want to get to use this tool and actually type some commands on your machine and generate images. Okay, the first thing is that you should input square images, right? I have an example on the generated images, and what happens there is that if you input, for example, a landscape image, the network actually gets a squared image, as I think. And if you give an initial image, it will stretch your image, generate, and then move it back. And if the image is narrow, it will stretch it out, generate, and then squeeze it back. The input contextually will make sense, but for example, if you're generating a face, the face is always going to be proportioned as in the dataset, and the dataset is going to be generated properly, squeezed or stretched, and then it will get stretched or squeezed the other way around to make it look like the original proportion that you had on your images. All right, so I see also John Pearson retweeted your link, figured out. I see what this is. That's nice. Okay, I'll give a thumbs up to John. I'll tell him thanks for doing that. And then Design Tech Unraveled said, I'm here too, working on some deadlines, some more listening. Oh, okay. So I see that John is also here. Awesome. So yeah, even if you're listening or hearing, if you have any questions, just drop them there. And if anything of this is interesting to you, we can, I can go in depth into any parts that you find interesting. Thanks for retweeting. All right, so input square images. Don't input stretched or other resolutions because it will mess up the output and it's a bit weird. Then test first. There is this -R flag that we can use on the framework, and that allows us to say, okay, I want this prompt and I want to generate, I don't know, I want to generate like, what can we say, like maybe 10 or 15 images, right? It will generate 15 images for you, and the other thing you can do is like the steps, put them really low. And let's keep moving because I'm talking about things that are really in the abstract, and if you haven't used this, it's a bit confusing. But we have a few flags that I want to talk about. So show progress, prompt strength, seed, and I think that's it. I think those are all that I have here, but we can see more of them. So show progress, as I said, serves for the algorithm to output all of the progress that it does. It's nice to also understand this diffusion process, what it's actually doing to predict and generate images. So that's also a good thing if you want to do animations, as I showed here. So this is with show process on. That's why it shows this predicted latent torch something here, because it actually has some debugging information on the image. So these basically are the predicted images along the progress work that it showed me. And I just make a GIF with ImageMagick. I just combine those at 30 frames per second or something like that. And all of these are also with the same technique. So, but then this one, so this one here, that's slightly different, right? That one actually is using an interpolation of the prompt strength, which you cannot do in one generation. You have to do step by step. So in prompt strength, basically is how much attention do we need to pay to the prompt that you're telling me, the text that you're giving me for the generation process. If you say 0, the network will just try to encode and then decode and generate an image that looks exactly like the input. If we increase the prompt strength to something like 6 or 7, the image prompt strength will actually get a lot of strength, and it will try to make your object look like what you're asking for. So the process for interpolating is that you do that, but you ask each step. You ask at 0 prompt strength, 1, 2, 3, 4, 5, and then you get a transition between your initial image and the one that you want to generate. What I was doing on my case, as we're going to see more images now, is that I found a way to make a boomerang loop from start to end and to end to start, waiting for like half a second on the first image and half a second on the last image. It's a one-liner. It's really easy with ImageMagick. It's basically inputting the images on the directory and then inputting the same images but reverse. With one command, we can do that. It's really simple. And then the seed. The seed is really important because when you add the -R flag that I was commenting before, and actually it might help if I open a new terminal here and start looking at some code instead of just talking about everything in the abstract. If I look here, go to the desktop, let's make a directory, just gonna call it Imagine, and we're just gonna enter that. So in my case, I'm not gonna explain today how to install this thing. It's on the well, are we explaining that? Let's, I think if you have the dependencies and stuff, you can simply do pip install imaginAIry and everything works, right? So pip install imaginAIry, and we're just gonna show this here really quickly to kind of say that that's it, right? So in my Conda environment, what I have done is that I already have an Anaconda environment. I can just say Conda activate imagine because I've called it the same way. And then inside of here, I have my imagine command, and I don't know if they have the help thing, but yeah, I have the imagine command. So when I'm talking about the imagine command, like this imaginary framework, I can say imagine a house. And if I click enter, it will start thinking, it will generate an image. But there are flags that you can add here. So I could add the flag show work, for instance. Let's put them, I think, I'm not sure if you have to put them before or after, but you can say R and say 5, this is what I'm talking about, and it will generate 5 images of a house with different random seeds. You can actually specify, in this case it wouldn't make too much sense, but you can specify seed 100, and then you need to remove this because you're just going to generate, I guess, the same image if that works that way every time. But the thing with seed is that if you generate, let's say, 15 images and you like one seed, you can remember that seed and then do the prompt strength variation with the same seed. So then you're going toward the same place, but at each point you say, okay, seed strength, like prompt strength 0, then 1, then 2, then 3, blah, 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 until you get the result. And then you have that transition from start to end, right? All right, so okay, so let's leave this here. Let's leave this here as it is. So we have like a sample command here, and let's move to our slides again and continue with this. And then we have upscale. You could also run like put upscale there, the flag upscale, and what it will do is that it will generate a 512 image, and then it will apply the upscaling algorithm to make it larger. All right, so this Disney Pixar, I became a bit obsessed with like generating these type of images with my face and other people's faces, right? I'm just showing mainly mine, not to show other people's faces, but I'll see if in the future I can show some of the other experiments that I've been doing. And in here, this was a close-up of the image that I've been using for the video thumbnails. And you know, the closer it is, the better detail it will add, or the more details it will respect from the original image. The smaller we make the face, everything in context will make more sense, but the face itself will start taking, you know, losing a bit of definition, which is evident, I guess. So this was just that close-up. And then I tried to generate an image of, you know, the zoomed in, just the gesture that I'm doing right now. So let's see, basically something like this. And here you can also see that, you know, we have that GIF animation going from original to the generated image. And if we take that out, this is what I was explaining before. So we have here the prompt strength, and these are actual values from number 2 of strength on the left, number 3, 4, 5, 6, 7, and 8. And what you can see on the 2 is almost the original image. It was touching up my eyes a bit and making my skin a bit more reddish. And if we move to the right, we start seeing how the image starts changing more and more as we approximate like values like 5, 6, 7, and then 8 for the prompt strength, right? So just with one single command, right? Like this is actually more commands in a loop to generate multiple images. Just with one command, say, this is my input image, and then the prompt Disney Pixar, you can get to that animation that I was showing, to that image on the right. And in this case, then I touched up slightly the appearance of the final image in here to make the color tone like look a bit more similar to my skin tone, and touch up a bit the eyes and stuff. So with this, it's really exciting. And also the image that I'm showing here is upscaled. So that was to get a higher resolution. So it looks crispier and looks more detailed, right? So that is one experiment there, interpolating there and then getting that prompt strength path, let's say. I don't think it's exactly like latent space walk in this moment, because we're always generating toward the same image in the latent space, but it's something relatively similar. So in here, this is a different concept, right? Here I'm explaining the seed. So the seed means that I was getting the same input image, the same prompt, but using different seed numbers. In this case, I was controlling them to get deterministically from 100 to 110 or something like that, and see, pick from those which image you like the most. And then from the one that you like the most, you can go back and say, okay, from that image that I liked, I'm going to then make the prompt strength interpolation to the image that you want, or you can choose the one that you like and say, okay, that one that I like, I'm going to upscale. And why am I talking about this thing of like trying and like doing some trial and error to find the images and the seeds you like and the images that you can generate and all these things? Is because this is actually a slow process on the machine. So it takes up to a minute or like seconds, depending on how many steps you put on the image generation to generate an image. The fewer steps, the less you'll go toward defining an image. And after like 50 or 60 steps, as the repository says, you get more definition, but with diminishing returns. So you actually don't really you get more from like step 1 to step 20, and from step like 20 then to 40, than from like 60 to 65 or 60 to 120. Because I've tried, and if you go above 60 something steps, you don't really notice, and it's taking you the same amount of processing to generate those images. So my recommendation is 41 or 40 steps, 20 something steps if you want to do something quick and many iterations. But when you're at like 20 somethings, 30 somethings, at 40 steps, you already get an idea of what the algorithm is going to generate for you. And then you can choose to go up to 60 or do other things like upscaling or prompt generation, so prompt strength interpolation, when you have selected the image that you like, something that you're happy with and that you think, okay, this is worth for me generating, and I can spend the time and the resources, because otherwise it's going to take too long, it's going to slow you down. And yeah, this is just things that I've discovered to make my workflow more efficient and to be able to generate sample images for this presentation as well. And I think, yeah, this is it. So this was an overview, or like the high level overview on what imaginAIry is and how you can generate images with InstructPix2Pix. This doesn't end here. I'll remind you that you can subscribe and get notified when I go live next if you click on the bell. And now what we're gonna do, because this was just an overview and I just wanted to kind of explain and show some of the experiments I've done and how you can use it. Now we're gonna see a hands-on demo, and we're actually going to do coding. So let's get coding. Let's see how we can actually get our hands dirty and generate some images. Now would be the moment when you guys that are online, if you can leave whatever you're doing right now for a second and write on the chat ideas for things that I can generate. That will make it a bit more interactive, because you can see, you're telling me a prompt that I'm going to use in some way on the machine, and then I'll tell the machine to generate those prompts, and we can try it. But I'm gonna go step by step, and we're gonna try different things on here, right, to generate images. So if you guys want, just write some prompts. We're going to continue now, and I'm going to generate some images and see some examples. All right, so the first thing I'll do, I'm going to get this to be a bit smaller. And let's see, what can we generate? What can be the first thing that we generate? So I'm going to say here, imagine a Brutalist building, for example. If I do this and I say, okay, give me, so let's just start from this. So I just say, imagine a Brutalist building. If I, okay, so this is a simple prompt on imaginAIry. I'm just saying, imagine a Brutalist building. I hit enter, and there are many default values for parameters. So we have, for example, prompt strength is set by default at 7.5. Steps is set by default at, I'm not sure if 15 or something like that. The seed is random, so you can see steps are set to 16 by default, and you get actually 15 generation steps. And there's some other things that, okay, so when you get here generating a Brutalist building, 512 by 512, it tells us here generative prompt, so negative prompt, ugly, duplication, duplicates, mutilation, deformed, mutilated, mutation, twisted body, disfigure, bad anatomy, out of frame, extra fingers, mutated hands, poorly drawn hands, extra limbs, malformed limbs. So all of these things are things that are being negated to the input prompt by imaginAIry. These are things that are proven to improve the quality of the images and to not show grotesque images and things that we don't want to see, like strange mouths, grainy, blurry, right? Yeah, fused fingers, so missing fingers, so things that are negatively input to the model and are going to be taken into account, but to remove things from the possibilities that are generated instead of to add them, right? So if we open, so I'm going to open side by side here this image folder with the generated images, and what we're going to do is we're going to make this full size, or not, no, because then I'm not going to be able to open properly. All right, so our first generated image, this is a Brutalist building generated in 15 steps or 16 steps with prompt strength. You can see the number here of 7.5. The quote is a Brutalist building. So it's nice that it's actually saving some information, some metadata to the generated image in its name. And this number here is the random seed. So this is a really big seed, but we can actually now do some operations to this thing. So I'm gonna take and copy this seed here, because we're not gonna use it for the next image. We're gonna now say, imagine a Brutalist building, and I'm gonna say seed is that number. Oh, wait 1 second. So now I'm gonna generate an image with a given seed. So I'm gonna input the seed, and I'm going to say a Brutalist building, and then I'm going to say seed is that. And that's the number we've got from the previous image. And I'm going to say here, steps are going to be now 41. I do 41 because it always shows one less step there, and I guess that means that the initial step is not counted or something like that, and to make it more even. So you can see here, it's actually setting the seed to this, the prompt strength to this, the steps to this, and the sampler type to this. So those are all parameters you could change. And then you have the negative prompt is set to this automatically. I guess that we can override that. Oh, wow, it's super cool and really quick. Yes, it's really quick and super cool and really easy. So this is an image that was generated in no time. And now you can see that this image is going to take a bit longer, just basically like 25 more steps. And we'll get the same image a bit more defined because we've generated for more steps. And, you know, this is more defined in stable diffusion terms. It's not that it's exactly the same image more defined. That would mean that we're upscaling it. It's more defined in terms of like stable diffusion trying to get closer to the concept that we're inputting. So it's making it more brutalist and it's making it more look like a building. So this is the first one with 15 steps, and this is the second with 40 steps. So what can we do from here to show something easy, right? Even if this image has taken less steps and might have a bit less definition for some things, in this case it doesn't, because it just looks like a building as well. We can, and this is raw imaginAIry, so this is not InstructPix2Pix yet. And what we're gonna do, I'm gonna go with 16, the initial steps that we have for the same image, and we're gonna choose upscale. This does take some time, so it's gonna take a bit more time than before, but the generation time will take the same. So we're gonna take just those 15 steps. And now what we're doing is trying for the first time here the upscale flag. So we're upscaling the image. It's generating for 15 steps as this one did. So it's gonna be, we're gonna get the same image. This is 512 pixels width and height, but it will get upscaled to 2048 and we'll get more resolution, which means that we will be able to use that image better than what you can do with a 512 image. All right, so automatically I didn't do anything, just set the upscale flag, and this is telling us upscaling the image using Real-ESRGAN, right? Which is pretty cool. I have also used Disco Diffusion previously, says Jay Vallira. Jose Luis actually showed me, I haven't used it yet, but I found that this was super easy to set up, super easy to install, and really quick to run. So it was really fun. Okay, so while this is getting done, I'm gonna check on something here on my screen. So I wanted to do, okay, so I'm going to see if we can open Photoshop to do some testing, because so what difference between Stable Diffusion and Disco Diffusion? I'm not sure. I don't know the answer to that question right now. Maybe Jose Luis knows, I'm not sure. So we're gonna do stuff with Photoshop right now, but like what you can see is that I generated this image and it looks exactly the same because it's the same image. It's just generated twice, same seed, same prompt strength, same number of steps. And what we can do in here in upscale is that now we can open this image and we can see how much more resolution this image has than the one before. So we're gonna compare side by side. This I think is pretty cool, right? So I'll get out of the equation. And what you can see here, if we start zooming in, so 1, 2, 3, 1, 2, 3, 1, 1. Up to this detail, the image on the right still stands, right? Like you can still use it. The one on the left is completely pixelated. And I'm not sure how you can see it on there, but I see it really pixelated in here. Let's go to one of these details, for instance. Right? So yeah, that is pretty evident, right? Like we've scaled it, and the image size of this is 512. And the one of the upscaled image is 2048, as I said before. Okay, so that's for upscaling. What else can I do here so you see something? We can go with the same. So let's now take a look at the same seed, no upscaling, same steps. So initial steps is 16. And I'm gonna go now with, let me see, can I, yeah. So I'm gonna go with prompt strength. So the default is 7, oh, 1 second. Sure what I'm doing here. Okay, so yeah, so I'm gonna go with prompt strength. The default is 7.5. So I'm gonna set it to, let's do one with 6.0, for example. Yes, and here on the chat, Jay Baida is saying that Disco Diffusion is a lot slower, but you can use high resolution images with it. I personally haven't used it. I've seen some really amazing results, but I think this is really promising as well. I think the technology behind it is really similar, the model. So yeah, I would love to see if somebody can comment on what the differences are. That would be really good. All right, so we got that generated. While we look at that, I'm gonna go with 8.5 as well, so we go above. And what you can see here, so now we have this and this, right? So is the image with also 15 steps in both cases, but this is prompt strength 7.5. This one is 6, and we're gonna get to 8 in a second. And Jay Bajira is saying that we can use this prompt, a huge gold kinetic sculpture inspired by Stingray. Okay, so we're going to use that in a second. So this is 8. So this is with prompt strength 8. So this is this would be a way in which we could, so if I copy these ones to the temporary folder and I sort them by strength. So for example, I'll say this is like 006, so this is like 006, this is 0075, and this is 0080. You can see now in order, right? Like this is going in a progression of image generation. How would we generate a transition from one to the other, right? And what we can do is a for loop, right? So if we build, so let's take a look now at how to generate an interpolation of images with a for loop. So we actually set that the prompt strike is gonna go changing values, and we actually make a GIF animation out of it, right? So this is how to make a GIF, how to make an interpolation with the prompt strength. So we're going to do here a batch loop. If I remember, right, the easiest way to yeah, okay, so we have a question that I test. Okay, we got sound again, so I'm gonna restart. I don't know where I stopped. Okay, now we have audio, so I would appreciate if you confirm it on the chat. But okay, I'm gonna start again. All right, so I'm gonna answer Jose Luis's question. All right, so I'm gonna answer Jose Luis's question on the chat that says, what would your MDes, my master's thesis, look like if I did it today with these tools? And I think the possibilities now are endless. I think I should go back and build the browser web app that I was building for collaborative drawing, because this now allows us to input any drawing and just have a task with like human language, say like make it a flower, make it a daisy, make it a sunflower, do things like this. And I was actually trying the other day, I'm gonna bring some examples that I was testing with, but I didn't get great results with that task just yet. If we see it here, these were some of the images that I was testing with. And, in some way it works. It's trying to make so that the original image looks more like this, like a sunflower. And this was trying to make it more into something that looks like a daisy. The colors it was respecting, but the flower indeed looks slightly more like a daisy, right? So we have that possibility. I will show something with this example as well. There are many things to cover. Probably not gonna be able to cover everything today, but there is a generation. So for example, I have a GoPro drawing that looks like this, right? So if we actually go into sketch.node.map, I published this drawing not long ago, right? So this is a hand sketch. I draw it, I scan it, and then I have it there. Well, what would happen if we ask Stable Diffusion with InstructPix2Pix to make this into an actual GoPro, right? We have the answer right here. So these are images that were generated by InstructPix2Pix from my drawing. So from something, let's see, we can open this in big, from something that looks like this, we're getting something like this, right? So it's actually just like a hand drawing, and it knows about the context, it knows about the shape, the proportion. I don't know, it just knows how to put a lens in there, and that this is a piece to hold the camera, and that this is the camera. It gets a bit confused with the text because it tries to make everything into a GoPro item. So it tries to make them as batteries or like cameras from sides or things like that. And it's not, I don't know, it's a bit weird, but it's impressive. And we can see what the interpolation for this image actually looks like. And it looks like, not here, maybe here. Yes, it looks like this. So this is the interpolation of one of my sketches into a GoPro, and this takes not a lot of time to do, and it could be an awesome way even to animate, to use this animation on a collaborative drawing board, that you draw something and then it just animates once into the suggestions, like boop, like this is what I think a GoPro is, right? You just draw a sketch and then you say make it into a GoPro, and then you do it. But in some way, what I like from there is that you still need the skill of being able to represent something as you want it. And one thing that would be really cool that we can even try today or in the next live stream is like we can rotate the sketch or animate something and have it generated with the same prompt strength and get really good results as well. All right, so one thing, for those of you who are connecting now, I would love if you say hi on the chat, and if you tell us where you're connecting from, and give me a thumbs up on the video if you're liking it, if you want to see more of this stuff. There are many experiments, like many things that I've been playing with that we can take a look at. Where were we before Jose Luis's question? We have a prompt there from Jai Vallira, and we have also, we were doing a bash loop here. All right, so back to the bash loop, and we'll get back to the chat in a second. So how do you make a bash loop in the easiest way, right? Like the easiest way I know is like for I, so i's are range in, and then you pass arguments. So for example, let's do here 542, 500, and 1, 2, 3. Then you say do, and then you say echo, right? Like just print that variable. So now I'm going to say done, and then I click. And what's happened here is that I've defined a piece of text that actually if you were to edit it into a file, into a bash file, it's fairly simple, and it just iterates through our execution statement. So what a bash loop looks like really is something like this, right? This is your command, this is the definition of the for loop, and this is basically saying like, for this, do what's inside here. And one thing that we can do, I can save this into loop.sh, and I can do sh or bash, right? If I do bash loop, it executes, but I can also do sh loop sh, and then it executes, right? So one thing I like to do is put clear in front, so every time we execute this, we just get the clean output there, right? What else can we do here? We can have words. So we can have Nono, we can have Jay, and we can have Jose, and we can have John, and I can run it again. So we will run for each of those. So what is the intention of bash loops here? One of them is to loop through values, right? So one way to do it would be, okay, I want prompt strength to be 7, and give me just one tiny second. Give me just 1 second. Okay. All right, we're back. What happened here? Okay, great. So I'm back. Sorry guys for that. I had to take a call. All right, so where were we? So I was explaining how to do loops in Bash. And I was going to say that, one thing we could do is that we could write here values by hand and have these execute. So for example, I can even run it from Visual Studio Code. So I can say, okay, let's go to that folder and say, okay, clear sh loop sh. So I get these values here. And one easier way to do this, if I zoom into here a bit, is to reproduce this. I will do a sequence. So let's actually try first that command on terminal. So I can do here basically a command that says sequence from 6 on steps of 0.5 till 8. And that outputs that sequence of numbers, right? So we could say from 0 to 8, and then we just get all of the points transitioning from those two ends. So what I'm going to do is I'm going to put that here so it outputs those numbers and see what happens. So now we do that and the result is exactly the same. So we are actually here, we're looping from 6 to 8 in steps of 0.5 and then printing that number. What could we do with this? We could actually build a command. So we could actually say here, imagine a Brutalist building and then prompt strength I. And if we do that, we're actually getting generated the commands that we need to run in order to generate this image 5 times, interpolating from start to end. If we now remove echo, which is just like printing on the console, I can simply go here. Every time we generate, I'm gonna clear the screen. So I'm gonna say clear. And we're gonna say, for example, we could say echo we could actually print the command as well, but let's see if we can. This is a nice thing. So I'm gonna do here, the command is gonna be defined with this line, and then we're gonna print the command. So I'm just gonna do this just to try if it works, and we'll only see the last one, I guess, here at the moment. Let's see what's going on here. Export command. Brutalist building, blah, blah, blah. Let's see if this works. All right. So because we're clearing, we don't see anything, but if we were not clearing, we're getting that on the terminal. So that works. And what I'm going to do next is execute to see if we actually execute that command. So we're going to mention that command. And we're going to now run that command. So execute the command. And I'm going to run it. Okay, so now we say that command. And it's actually now executing, running that prompt, I think. I mean, I think that's what's going on. So if it, maybe by doing it this way, it doesn't print. Okay, so it's printing now. Okay, it only prints the percentage. I'm not sure what's exactly going on behind the scenes, but it's not bad because we just see the command and the printed prompt. All right, let's see what's going on in the generated section. All right. Brutalist. Okay. I see. Okay. So it's not working properly. It's actually, let's actually just run it without printing because otherwise it's gonna be a bit confusing. So I'm just gonna do here this. So we have that as a prompt. So this is gonna execute that properly. And the only thing I'm gonna print here is gonna be the prompt strength. Okay, let's try again. And I'm gonna wipe all the images in here. So I'm gonna put here generated archive and run that 1.0. So we generate with prompt strength 6 And now we're gonna see all the generation steps. All right. For some reason, this is now generating a new snapshot. I don't understand why, but and okay, so generated. This is the first image from the interpolation, and now we gotta be a bit more patient because this is gonna take some time to actually generate, and we'll have to wait. So we're trying prompt strength, and I have a command then to generate a GIF from there. I do have commands. So if I open here projects live 95. Oh, 96. If I open this, or maybe we open it in Visual Studio Code, this actually, I have some automation that I can put. I need to remember to put this because I have this on my machine. Here we're getting an input image, and we have parameters for the start and end and the step, the seed that we're using to generate. Then the prompt here, we can actually input one or more prompts here. We can put here like a house or something. And then what this does is basically just naming the folders properly, and then moving the images to a specific place and making that GIF that I mentioned before. So we're gonna see that in a second now. All right, so we have this script here, and we're generating, and I think this is our last image that we're gonna be generating. Okay, you see, I made a mistake here because each image is on the right prompt strength, but as you can see, they each have different seeds, right? What this is useful for is that now we can go and say, okay, I have these images, and we can choose which of them we want to interpolate towards, because we can choose a new noise from here. So I'm gonna choose this one in here, and we're going to move them to archived, and we're gonna modify our script here to say image, and we can actually put this syntax like this. And we're gonna have seed be that number. All right, so let's run that once again and start generating from scratch. Okay, so okay, so let's see. I'm gonna take a look at some things while we're generating these images, and feel free to write any questions on the chat. All right, we also have here, I'm gonna copy the prompt from Jai Vida, a huge gold kinetic sculpture inspired by Stingray. All right, I'm gonna prepare that in here, conda activate imagine, and we're going to say imagine a huge gold kinetic by Stingray. And let's put here seed 100 so we can reproduce that, and then we'll choose 41 steps. I'm gonna wait until this finishes so we get more, we don't overload the machine. And we haven't still used still used InstructPix2Pix. So all of this has been plain Stable Diffusion imaginAIry. So let's just wait for this to fulfill, and then we'll be we'll be trying it. All right, so this is almost done. While that starts, I'm gonna set this one up, a huge gold kinetic structure inspired by Stingray. All right, and so we have here an image. So let's see how that looks. All right, so now that interpolation makes more sense, right? So now we're going from this to this to this to this to this. And we could get it to be smoother if we get the in-between images as well. But for now, I'm going to just use those. So I'm gonna put here, so generated, let's put here a let's just copy from here. Okay, and that is generated archive. So we have this one that Jay Beta mentioned. So this is a gold kinetic sculpture inspired by Stingray. So yeah, so it looks like Stingray. It looks like a sculpture that is at a museum, maybe the Tate Gallery in London or something. But as I said, you know, one thing to see which one we want to generate the most, we could say, okay, give me like 16 steps and give me 5 options, right? So we're going to say, give me 5 options, and then we'll continue and seeing those. On the meanwhile, as I said, we're going to generate a GIF out of our interpolation of the prompt strength, and we have them here. So I have my code already, so I'm gonna reuse it. I don't need to reinvent the wheel. If I explain a bit what this code actually means, so if I get it, let me just move this a bit so we see it cleanly. This code, really, what I discovered recently is that I can, let's see it here. Okay, what is this code really doing? Let's see it. Okay, so convert is, let me see in there. Okay, convert is a command line tool, a binary provided by ImageMagick, which is a command line open or free image editing tool. So what we're going to see is how to generate a GIF by having those images, and not just a GIF that loops through your images, but a GIF that stops a bit on the first image, transitions to the last one, stops a bit, and then comes back, and then it loops continuously, right? So here we have the convert command, right? So we say convert, and then there's this delay flag that I'm putting before input images. 1x2 means 2 frames per second. 1x30 is 30 frames per second. You can go, I think, from 1x1 to 1x30. I'm not sure if you can go above. And then if you want longer times than 1 second, you can specify like 200. I'm not sure if that's milliseconds or what it is. But what I'm doing here is, if we have an output dir, so where our images are, we're saying, okay, delay for half a second, and this command gives you the first image on the tail of the directory. So it lists from that directory, and then it gives me the first one, and then this one gives me the last one in the head. And then here I have a command that lists the entire contents of the directory. And then here I have the same command with the R flag that reverses the list. And then we have the output path for the GIF. So the first thing we have to do is to export the output dir variable. So I'm going to do that. And we are here in outputs, imagine outputs. So if we see outputs, we have, this is our output directory. So we're going to say output dir is actually outputs and that. So this is our output dir. And if I now echo output dir, I get that here. So the command is already able to use it. If I show you here, you can see this command in action. So we list the first image is actually the 0, 0. And if we change this to head, we get the last one, which is number 4. Do we have more? Yeah, 0 to 4. And then if we choose to do this command, no, this command, we're actually listing all of the images starting from 0 to 4. And if we add the reverse flag, we're listing from 4 to 0. So I did my homework. You don't have to do it. You can just copy this code or write it on your computer, and that should work. So when I do this, right, if I put this here on the side, what you're gonna see is that after I run this command, it's gonna generate a GIF in here, and that GIF is already what we wanted. Right? So it interpolates a bit fast, I would say, for how many images we have, but it does the job. So if I get out of here, this is an animated GIF from a Brutalist building from prompt strength value 6 till value 8. So we have 5 images, and we pause for half a second in the first and the last images, and then we pass with like 1/30th of a second for each image. So we have like the equivalent of 30 images per second. But we only have 3 images to transition from image to image. So if I can here, right, for just a moment, I'm not gonna change my file because this is what I'm using. I can put this to 15, right? I can copy that, and then I can rerun this, just adding a note that this is a slower version. And then we can see that animation a lot better. And this is actually a nice one. If we go 0.5 steps to 0.5 steps, we can actually interpolate a bit slower, and it also looks nice. So we could actually leave it generating just to get to that image a bit good. So I'm gonna make it again with this combination here. So we get the loop, and we actually put this in here. And you know, the extra steps that I have on my script here is that we define the so we have the prompt. So we have here the input prompt. So we define the prompt as a variable. And we put here input prompt. Right, so that's our prompt. And then I define this nice scaped input prompt, which in my case was more complicated, but I just need the input prompt and the prompt strength start, blah, blah, blah. Yeah, and then here we have the prompt strength, but I actually am setting these things here. So I set these variables here as well, the prompt strength, start, end, and step, which for us now are 4, 10, and 0.5. And we loop through those, right? So we loop through this. I'm gonna leave this as it was on the other script with J and J. And the output dir is gonna be the input promptscape inside of the generated archive directory. And then what we do here is that we create, if it doesn't exist, we create that directory after we finish with everything. We move our generated outputs there, and then we create the GIF. And in this case, just in this case, I'm gonna put here 15, so it generates with 15 later. And I think because this is our seed, I just put the seed here and change it here. And because we're not using InstructPix2Pix, we don't have an input image. All right, so I'm gonna generate again. So this is with the, just put explicitly here, the steps is 16. And let's make it 14 so it's slightly faster. Okay, so we say here we're gonna make our loop, and oh, it's not getting any strength values. Okay, why? J. All right, so we start generating, make sure. Okay, so one thing to note before we generate, we have here these images from the string array. From J, and this is what they look like. Nice. So each of these, we could now ask for more steps to define them better, and they would look a lot, I think they would look a lot better, right? For example, in this one, we could grab this seed and leave the same prompt strength. Now we say, okay, we want to regenerate this one, but now regenerate for 61 steps. And then we're gonna go to the same image, but like develop it a lot more. It might not look exactly as it is looking here, but it will be the same type of, this is kind of like a Pringles thing. Last one looks nice. Like, you mean this one? How can I know the one that you are referring to? So I'm gonna say this is number 1, this is number 2, number 3, number 4, and this is number 5. So you tell me from 1 to 5 which one you're referring to. Okay, so seed requires an argument. Okay, so the seed was this thing, right? From this one. Yeah, this one is also nice. Yeah, I'm not sure. So you say 1, 2, 3, 4, or 5, or like a couple of them. Otherwise, it's difficult because we're a bit out of sync. And again, I'll remind anyone who's watching, if you like this video, you can support the work that I'm doing here. It also means that you're enjoying. And make sure that you subscribe and click on the bell to get notified when I go live next or when I upload new videos. And if you're live right now and not watching this offline, feel free to write on the chat, let us know where you're connecting from. And if you have prompt ideas, I can give this AI an idea and it will let us know what image it generates for that prompt. All right, so I see 4 and 5, and I can generate, once this finishes, option seed requires an argument. Yeah, so I'm going to wait and we'll generate both at 61 steps in definition. Oh, now it's generating 5 for the same seed. I'm not sure if that means that it's going to generate the 5 images exactly the same. Let's see. Let's take a look. So it generated this one, which is the same one, but slightly more detailed to make it look more like a stingray, but it's the same road, the same street. So I'm curious now what this one is gonna do, if it's gonna use the if it's gonna do the same. Yeah, it generates the same. So don't use the -r with seeds. So just use either or. Okay, so I have here now, I'm gonna input the, oops. I'm gonna input the seed of the 5th image. We're gonna generate at 41 steps. And now, while that's been done, I'm gonna make sure everything's good here, because we're gonna generate again the Brutalist buildings to generate a transition, make it that the sample of the live stream. So we're gonna do here loop sh, and this one is generating now. So I'm just gonna run this. Prompt strength 4. Oh, okay. I know why I didn't start running it. Because as soon as you start running it, you define the number of the image here. You see this is 0001. And I don't want the count of the number of the new images to start in 2. Okay, so this is almost finished. And okay, so now we can move this into the Stingray folder. Okay, so here is the nicer version. That looks really similar, right? It looks really similar, but one has more steps defined. And we could also use Upscale to generate some of those. Okay, so if we have now emptied the generated folder, which we have, I'm gonna start this loop. Actually, I am new in all this AI stuff, so sorry for the new question, but can you tell me which software you're running, and is this Python language that is used to write the AI code? Okay. So the program that we're using, and this is a completely okay question, this is what I'm here for, it's called imaginAIry, right? So I'm gonna put the code in there. So that's a repository, and you use, it's indeed a Python library that you can use as this thing shows here. So you do pip install imaginAIry, and then you just run a command like I'm doing on your terminal. The thing is, you need Rust as a dependency on Mac. On Windows, I'm not sure. You just need Python install and then run this command on the terminal to be able to install imaginAIry. I guess like if you don't know anything about this thing, you'll say how to install Python packages on Mac or Windows and look for instructions. And you know, one thing, I clicked the wrong button. And what was I gonna do? Okay. So one thing that I want to show, because Jay here is asking, like, if you don't know anything about coding, how do you run this, right? One way is I'm gonna create here. I'm gonna show a Colab notebook. So I'm gonna show some way to run this on the cloud for free and without having to set up anything on your machine. So I'm here in Google Collaboratory. So this is at colab.research.google.com, and you have access with it with your Google account. So if you have a Gmail account or you have Google Drive, you have access to this. I'm gonna set this up as imaginAIry, and this is live 96. And I'm gonna show here using imaginAIry to generate images with stable diffusion. We're gonna add this as text. Notebook by Nono Martinez Alonso during live 96. So this is nono.ma live 96 on today. All right, so that's my title. And the things you need to do here, yes, so you can run here this ban command to install packages. So you can do here pip install imaginAIry. And I think this should work off the bat. So let's see, I actually haven't tried this, I think, here. And we're gonna say that we want to use GPU to see if this makes it any faster. So I'm just gonna run everything here. So this is gonna be installing all the dependencies and all the packages here. And we'll see if this works. And here we're generating, right? So we're still generating images for our interpolation of Brutalist generated building. Oh, okay. So we have a mistake again between a Brutalist and blah, blah, blah. So I'm gonna have to stop this again. So we gotta quote that, and I've deleted the images. I'm gonna rerun this again. All right, so let's run that on the background again. Okay, so this is installing all the dependencies for imaginAIry to work in here. So I guess we would have to run here imagine a house hanging from a balloon Disney Pixar app. Let's just see if that works. And I'm gonna share the link to this so you can use it directly, just changing the so this is a notebook to run imaginAIry generations in Google Colab. All right, so this is working there. This is also working, right? So we're generating images in here, and this interpolation looks, yeah, it looks pretty cool. When this finishes, it should generate a GIF automatically. So it's already set up so the script sets and creates that by itself. All right, I think we're running a bit late and I haven't been able to show everything. So I think I'm gonna have to do another live stream on this. This continues generating. So one thing that I want to show, so if we make a 1024 by 1024 image here, actually let's make it a bit bigger just in case we make something nice. Okay, so I have this canvas. So first thing I'm gonna do, I'm gonna save it to my desktop folder, the one that we have in here, imagine. And I'm gonna create an input folder and I'm gonna put here, for example, flower. So I can draw here something like this. So let's say I make this like that, and I can even color that. So let's say that I give it some color. And now I'm gonna make some petals. So I'm gonna make like a petal is gonna look something like that. And this is my petal, right? Okay. So we're gonna put my fill is gonna be just a plain color. And I'm gonna have many of this. All right. And, you know, now I'm going to do, so I'm drawing here a flower, and what I'm going to do now is that I'm going to make it so all of these things don't show up in the center, right? So this is my flower. I can actually move it, and I can also group it and center it. So this is our flower, and I'm gonna just save this as a JPEG. So I'm gonna say, okay, my JPEG in this case is gonna be a flower. Awesome, we have it here, and we're gonna put it on the inputs. So now I can use that as an input for InstructPix2Pix. And let's see how this thing is, if it's finishing, because it's gonna finish up really soon before we move into something new. Okay. Close that. All right, and here we have our new Brutalist building. All right, so we just need to wait for 2 or 3 generations, and then we can move into the next thing. So let me take a really quick break while this generates, and I'll be back. Okay, let's keep going. All right, so we have, what do we have? We have this thing here now. I can see some people are connecting online, so please say hi on the chat. Let us know where you're connecting from. And make sure that you subscribe and click on the bell so you get notified when I upload new videos and go live next. Okay, so this has generated, and if it said is done, it means that it's also generated our animation, and it has archived automatically the thing that we just made. But this may have not worked as I expected. Has it done it or not? Where are our images? Okay, let's see what the script says. Okay, so output dir in this script is not defined, so I forgot to do that. So what we can do is see what value output dir has. So it has outputs this. So maybe it had already finished. .307, 307, this one. I'm missing something. Hey, Juanda. Yeah, Pixar style. I remember you showed me some of those as well. Okay, so they're here. All right. So yeah, I have, well, Juanda, hi, what have you been up to? I'm so happy to see that you're able to connect online today. We've been playing, I've had so much fun this today's live stream because this is some of the things I really enjoy. So this is our Brutalist building, right? A Brutalist building, and we're interpolating from start to end at 15 frames per second in a GIF. So we're going back and forth. And, you know, just so you see it, we could change it here, for example, to, so let's actually add here export frames per second is going to be that variable. And I'm just going to use that variable here. And also I'm gonna add it here. So that is at 115, but we could do 130. So I do here that. Oops. Oh, okay. I know what happened. Or not. Let's see, echo output there. All right, but this is here. Okay, so we move from there to here. We want the, let me see. Echo output there. But that doesn't exist anymore. We're a generated archive. So we have somehow to do here export output there, generated archive, and that. So now we try to run our command. Nope. Okay, let's go one by one. Oh, okay. So we actually have a different output there. Okay, I'll figure out what's wrong later, but I'm just gonna put the right value here. So I can just run the GIF command. So we see this is faster interpolation, right? So this is a faster interpolation here. So you can see it in there. 30 frames per second. And if I go out now, I can run the same, but at like 5 frames per second. So now we run the same command and I hide again to show you this at 5 frames per second. So it's whatever you wish, depending on how detailed your interpolation is. You can choose from different different speeds and different things. All right, and just the last thing I'm going to show before I go, because I do have to go now. I have a flower here. So let's take a look at how to actually use InstructPix2Pix, which I promise will doing this live stream. So I'm gonna say a image, edit, and I'm gonna say inputs flower.jpg. And what do we want it to be now? We can say it's a daisy flower, or maybe we just put daisy flower there. And then we're gonna say steps 41. And we're gonna add one thing, is show work. So while it's generating, it's actually going to be saving to a different folder the steps that it does, the conversion from image to noise, then the diffusion process, and back and back and back and forth. So we're here. So this is now gonna show InstructPix2Pix, because as soon as we don't use the imagine command, we use the AIMG edit and an input image, then this is using InstructPix2Pix, which is actually getting it from the Hugging Space models. And that's already generating. So for each step that we generate, we're going to be getting a stepped pass in there. So I'm going to go to the outputs directory, steps, and then in steps, we can actually see from the beginning, right? So this is some tensor from our initial image, generates some noise, and it does diffusion with that image. And we actually see the generation process in here. And we have determined how the flower is gonna look from the input that we gave it. What's funny here is that the seed that this got is considering that the inner yellow is the actual green, so yellow daisy flower, and not the outside. So it's fun to see that. That's what I was mentioning before. Like, you need to pick well your seed, because maybe there is another seed that makes it work better than this. And for this, I'm gonna now make use of what I made offline, which is I'm gonna animate show work. Yeah, so this is it. So I'm gonna just copy this code. I'm gonna put here a new script that is gonna be instruct.sh. I'm gonna paste this, and I'm gonna say, okay, my image is named flower. This already takes care of the inputs part. I'm gonna say here Disney Pixar flower, and we're gonna put here daisy flower. And just to make it fun and quick, we're gonna put here 31, but I'm starting this 7, and we're gonna leave everything as it is, even though here I am tempted to do the same behavior as I was doing before with the steps. So let me see if I can quickly change this code while the other thing is generating. So we're gonna do still 30, we're gonna do 2, and this is our output dir. So we can say here export output dir that, and then we just have the same, right? I think that should work. Let's see if this works. So we are going to generate this, and this is our seed. So that has been generated, so we can examine it, and that's generating now. So in here I do have the new steps. Okay, so these are the steps that we're gonna take out from there. Steps archive, and I'm just gonna put this here and just put this here. So we generated this image, and I don't really like it that much, so we're using a different seed. But what you can see here is if I arrange them more or less by size, well, probably not by size, we just let's try to see them like this. Let's see where they align, if they do. More or less here. So more or less the generation process looks something like this. And this is what we can really animate, right? Hi, John Mark. I'm super glad that you could join today, I guess, because I'm staying up to a bit later than usual, because usually this time might work for you, but not earlier, I think. Yeah, okay, so this is one of the, with this input image, we were able to generate those. And now what I want to see is what these new steps bring us. So this is generate, kind of like spoiler alert. Oh, okay, so that one finished already. So where is that one? Steps archive, where did we put that one? Okay, and all right, wrong loop. So wrong loop, I had some logic here that I didn't put on my step predicted. So we need to put that. Let's see if this works. Okay. Now the variables have changed. So, okay, so I just need to go and define my export. So let's, yeah, export. So output dir equals this. Because we're in Imagine, we just need this part, and let's see if this works. All right. Let's see. All right, I might not need these things here. So let's try once again. Delay. Okay, so, all right, great. So I think I got it now. Nice. Well, that one's really nice. So this one, thumbnail for the live stream is funny. Yeah, it took me some time to make it, but with this framework, it was super nice. So yeah, this is what we made. This is what I thought that we could do. I'm gonna try to animate this one. This was a flower that actually, if we put it, maybe we can put it side by side. So we actually made this drawing on the left in Photoshop, and we animated with InstructPix2Pix. We animated it and produced the image on the left. So we could alter this image now and see how this output image changes. And actually, this is just the interpolation of the generation step, but we could have a really, like, a lot nicer animation if we go from this to the final image, interpolating through prompt steps and not through through just the interpolation steps that we have there. And I guess the other GIF is also gonna fail because the code is not right. So I have to do the same once again. So I'll have to do here, we'll have to re-export the output there, and hopefully that works. And it did. Okay. Yeah, and this is the other image. So both worked. just differently. And yeah, I guess that the last thing we can do, because I see some people are online, again, give me a thumbs up if you're enjoying this content and you'd like to see more of this on the live stream. And these are the last few minutes if you have any questions, because I have to go. It's a bit earlier. I don't know how long we've been going for, 2 hours already. And yeah, so let me just quote this. Oh, not retweet. How can I quote this? Can I quote my own tweet? Quote tweet. Things we generated today live. Here are a few things we generated today live. So this is Disney Pixar flower. Disney Pixar flower. InstructPix2Pix and Stable Diffusion. Okay, and then we have more tweets, right? This one. Goodbye, Jean-Marc. Have a good night. It fits very accurate to your sketch. Yes, so as Wanda is mentioning, the thing that I'm really liking from here is that it fits exactly to the sketch I made. And this is a great way to use this for like an extension of my master's thesis, which, you know, could be like fitting exactly where these things are. So yeah, I'm really excited that this works so well. And yeah, okay, I think we'll leave it at that. We'll leave it at that. And I think tweet all. Can we just tweet all? All right. Thanks again. Thanks everyone. It was a pleasure having you with us live today. And yeah, thanks for being there. Thanks for subscribing. And we can continue conversation during the week on the Discord server. You can join anonymous/Discord. I really enjoyed today. I really thanks for connecting live, for writing comments, for interacting on the chat. It makes it so much nicer than if you're not there. So thanks a lot for watching. Thanks a lot for listening, and we'll see you next time. Bye.